Assume you're standing at this point. Now, if your friend tells you there is a treasure pot 50 kilometers away from home, how long will you take to find it? Which direction will you go? It could be here, or maybe here. It is hard to know where exactly it is. You are only provided the distance, which is one-dimensional information. One-dimensional information like this is called a scalar quantity. Your question to him would be, which direction from home? When you are told that it's 50 kilometers in the northeast direction, you have the precise information of the location. This now becomes two-dimensional information, distance and direction. The treasure pot is over here. Two-dimensional information like this is called a vector quantity. Scalar quantities are one-dimensional and vector quantities are two-dimensional. Speed is a very good example of what we call in physics a scalar quantity, indicating only magnitude but not specifying any direction. So that's what scalar quantities are. Only magnitude but no direction. In the case of velocity, however, the direction is stated and that's why it is referred to as the vector quantity. A vector quantity involves not just the magnitude but also the direction. When you add directional information to speed, it becomes a vector quantity called velocity. The additional information makes it more specific. Temperature change, for example, is one-dimensional quantity. But when we specify rising or falling temperature, it is two-dimensional. If someone says that the temperature has changed by 2 degrees, we won't really know if it has increased or decreased. We will look at various scalar and vector quantities in the next few tutorials and for as long as we study physics. Speed, velocity, distance, displacement, mass, weight, force, acceleration. The more we look at these, the clearer this concept will become.